Hey, good morning, everybody, and welcome to my session. Certainly a very different way of presenting this year relative to last year, and a very different session for me. This year, instead of doing some motherhood stuff and talking about the big picture, I thought I'd dive into a topic that I'm really passionate about and spend a fair amount of my free time on, and that's IoT and building a smart home. I think before I get going, I just really want to make a shout out to Rob and Candice and the Ant Farm guys and everybody involved in DevConf for putting this together in the way they have. It's amazing that we're able to still connect under these circumstances. So it's really a huge shout out to them and congratulate them on doing such an amazing job. It really is a selfless effort for the community and for all of us. So really, really thank you to them. So with that, let's dive in. I wanted to kind of give you a little background before I jumped straight into what I've been doing. So I guess I've been into home automation for a very long time. I started way back, kind of always been tinkering in this stuff since I was a child. And about 20 years ago, before any of the stuff was commercial, I started building my own circuit boards even. And this nice dusty picture here is a picture of one of the first circuit boards that I built to try and control my garden irrigation system. I had to hook it up via a serial port to a PC that I built into the wall. I had a wireless connection to it, and it worked kind of okay until the lightning came around and fried it. And I think if you look carefully on this board, you can see how the lightning kind of blew up some of it. I then kind of progressed, and the industry kind of progressed into something that some of you may or may not know, called X10. And X10 kind of was a nice way to start putting controllers into your light switches, which I guess is where most people started in this space. And it took some hold, but the protocol had some issues. Connectivity wasn't always great, and I had a fair amount of experience building that up. I then had an opportunity a while ago to kind of look at this from scratch. We did some home renovations, and I thought, well, let me try and see if I can really build a smart home that does exactly what I wanted to do. And to try and orientate everybody into sort of what the smart home IoT space kind of looks like right now, I thought I'd draw up this diagram just trying to give everybody a visual picture of sort of where we are and various components of what I think a smart home are. It kind of starts out with the things here, so typical Internet of Things statement. But in my world, I think about it in two ways. I think about things that can take input and do stuff, and things that can provide output. And sometimes they're the same thing, but you sort of think about them in two big blocks. Then there's this concept of the protocols and how do these things speak to one another, but also speak to other things on the network. And we're going to dive into this with a fair amount of detail. Then there's a concept of control. And so if I have a whole bunch of things that can take input or provide output, how do I control those things? Both in the form of how do I provide a user interface on top of those? So how do I make it nice to be able to see what my stuff is doing? And also provide some automation around that. So once you have things and things can take input and provide output, you have the opportunity to do all kinds of interesting automations. As with any kind of good IT project, there is always this concept of data and where's my data stored? And these kind of devices and projects tend to produce a lot of data. And most of it tends to be what's called time series data. So it's based on linear time events. And there are some specific databases, etc., that exist to deal with that. So if we have time, I'll give you a quick view on that. And lastly, kind of incumbent with the control, of course, you need an interface. You need to think about the human beings and how they interface with your control system. And that can both be on displays, but can also be in other devices that you may not think about, like voice, smartwatches, etc., etc. And I'm going to try and touch on all of these aspects as we move through the presentation. So the first thing I wanted to start with was this concept of things. And things today, we're in the fortunate age of things really being, really, really abundant. There are tons of sensors, controllers, services that make up this world of things right now. I'll try to illustrate just a couple of them in the slide here. And you can see I just ran out of space very, very quickly. And they're more and more every day. You just have to go to watch some of the CES content every year to see some of the absurd things that are invented every year. But they really are becoming prevalent in multiple aspects of our lives, whether it be electrical switches or smart connected shavers, you name it. But for this talk, and really to start at the basics, and I really wanted to try and provide everybody with a practical way to get started in this space. So I didn't want to kind of come in flying and saying, this is what I've done. I want to take you through a step-by-step approach of how you can sort of get this stuff going yourself, provide you with a base learning so you can grow on that. I was talking to Candace at the last community event talking about this talk, and she made a very interesting comment that said, I really want to know how to automate one of the lights in my house. And I thought that was a great piece of feedback for me on, let's start at what most people actually think smart homes are about, and that's controlling your light. So how do I go from my light off to my light on in a smart way? So just some basics before we get going. For those of you who are not electrical engineers or have electrical background, a light switch is a pretty simple device, right? Power comes in at the top, it gets switched through a switch, and when the switch turns on, the light turns on. We all have these all over our houses and all over our buildings, and it's kind of commonplace for the way this works. If you want to turn that switch into a smart switch, what you need to do is replace that switch with something called a relay. A relay is a relatively simple device. It's really a magnetic switch. And what it does is it takes a little bit of power in on the one side, and that powers a little electromagnet, and then that magnet can switch a much bigger current. So we can use a very simple circuit board that works on very small amounts of electricity to switch a very large amount of electricity. What you also then obviously want is a way to control that circuit board. And there are many different control protocols around these days. But the thing that's super interesting for me right now is that the abundance of Wi-Fi to be able to control these things is really becoming commonplace. I'm going to talk with a little bit of detail about that just now. So what you really want is to receive some type of Wi-Fi signal on that switch and to switch your light on. Now, what would really be cool, and based on our experience, is that if you really wanted to, you could still add a physical switch to that circuit, so that you could choose to either switch it via Wi-Fi or by the traditional way of a switch in your hallway or in your bedroom. That's really important from a user adoption point of view, because if you just rip out all of the switches in your house and replace them with Wi-Fi, you're soon going to irritate the rest of your family because they have to walk around with their phones the whole time to turn the light switches on. So you really want to make sure that you still have the ability to use the physical way to turn your light switches on and off. Okay, so let's talk a little bit about the hardware in this space. As I said, there's really a proliferation of hardware. And if you start kind of looking around on the internet, you'll see that hardware is available in many different places from many different players and in many different types of protocols and forms. My favorites right now are two chips based on a Wi-Fi stack. So there is a Chinese manufacturer who's done an incredible job of producing a microcontroller called an ESP8266. You don't have to remember that. But basically what it is a very cheap chip that does both Wi-Fi and control in one chip. And there's various manufacturers who are taking that chip and wrapping it up into hardware. So you'll see here, there's a picture of a couple of devices. All of these devices have that ESP8266 chip baked inside them. And then you also get some other little boards that you're able to prototype. So if you want to mess around with some of the stuff just in an experimental way, you get some nice little boards to be able to play with the stuff without having to, put 220 volts in and potentially shock yourself. Just for interest sake, there is now an updated version of that chip called an ESP32 that is starting to make its way into many production devices. Much more powerful chip, but does very similar things. Has Wi-Fi on board and has a little controller built in. So let's talk a little bit about the commercial off-the-shelf devices. Kind of put this picture in long before when I was building the slide deck up in January or February, long before I knew where we would all be presenting from home. But many of the Chinese manufacturers, and certainly even some of the Eastern European ones, like to sell you stuff with their own firmware in it. And I guess like any big corporation, they want you to use their technology and be locked into their software ecosystem. Now, just getting started, that is great, and Sonoff comes with their own hardware and controllers and smartphone apps, for instance, and so do the likes of Shelly and many of the manufacturers. But the problem with that is that you get locked into their ecosystem, and then you end up having multiple apps on your phone to control your lights or whatever the case may be. Now, that kind of works okay when you just get started, but it gets very irritating after a while when you have 3 different manufacturers' devices and you can't remember, is the lights in the bedroom controlled by one manufacturer or another? But thankfully, we have our friend GitHub to thank and the huge, amazing open source community who does some really interesting stuff right now. So the demo I'm going to take you through just now is some amazing work that's been done by various open source projects. And there are a good bunch of them, but I'm going to choose to focus on one for this talk. It basically allows you to blow away the firmware that comes on these European devices or these Chinese devices and replace it with a firmware that is open source, completely configurable, and really allows you to tie it into your own home network and home automation system without having to go out onto the internet, expose your devices to the scary potential hacking, snooping, whatever you may think happens out on the wider internet. So my recommendation quickly before we jump into the first demo, and I'm very cognizant of time to first demo here, are 2 types of devices. The first one is made by a company called Sonoff, as I mentioned. The reason I recommend these is that they're available in South Africa. If you just type Sonoff into your browser with the .co.za search prefix, you'll see that you can get these devices somewhere between $120 for the one on the left. If you buy bulk, you can probably get it even cheaper than that. To the one in the middle, it is a super small little one that fits into a light switch. The Shelly devices are slightly more difficult to get, but you can order them on Amazon. And they're really nice and small and fit inside light switches. So if you wanted my recommendation on how to get started, which devices to use, I would go with the Sonoffs just because they're readily available here. They're cheap, and you can get going with them very, very easily. And my demo is going to be based on those Sonoff devices. So my first demo is how to flash one of these Sonoff devices with an open source piece of firmware. And what we're going to do is we're going to build up this demo over time to show you how we build a complete end-to-end home automation system. So just to orientate you, what I have here on the desk, what I'm going to show you in a minute, is a Sonoff device. I'll pop the lid off that Sonoff device, and this is kind of what it looks like inside. Most of these devices, as I said, are based on these ESP8266 chips, so this Wi-Fi chip. And the nice thing about that is that Wi-Fi chip is a standard, and most people know how to write software for those things who play with the firmware. Most manufacturers also expose 4 pins on their boards that allow you to actually program them, because they need to program them themselves. And what you can do is you can get a very cheap USB to serial converter, and you can plug it into this board, and then you can flash your own firmware on this board. The Sonoff devices all have these 4 pins exposed, and it's really, really simple to just pop off the lid and flash the firmware on these devices. So let's go ahead and show you how that gets done. So if you bear with me for a second, hopefully you can see my my desktop right now. You can see that there is a Sonoff device on my desktop over there where my mouse is, and I pop the lid off. What I'm going to do is I'm going to move over to the desktop, and I'm going to plug this pin port into the Sonoff device. It's got 4 pins on it that match the pins on the board, and that's based on a USB, and it's connected to a little USB to serial converter. So really, all that's doing is it's converting. It's creating a USB port, and it's creating a little serial output. Anybody familiar with serial ports understand that it's just a little bit stream for transmission and reception. I'm then going to power up this device while pushing this little button in the middle here. And when you power it up while pushing the button, you put the device into firmware mode. And the device is now programmable. So the little chip on the board is now able to receive programming instructions. Right, so now what I'm going to do is I'm going to launch a little utility. And that utility allows you to flash new firmware onto your device. If I can Alt-Tab to that little utility, Let me minimize this. You should be able to see my my Node MCU flasher here somewhere. And I'm going to move that over onto the desktop. What this little device allows you to do is it, although this little piece of software allows you to do, is it allows you to choose a different firmware to put onto the device, and it allows you to do that over a serial port. So I'm going to refresh the serial port. You'll see I've got 2 serial ports in my device here, and I'm going to choose COM4, I believe. I am going to browse for a piece of flash software. So basically where you get this is you head over to GitHub. Let's quickly orientate you here. There's a project on GitHub called Tasmota. This is the firmware I was mentioning. And they release new versions of this firmware really, really often, probably every couple of months. But you can see it's an incredibly active repository. And all you do is you go to releases and you download the binary versions of the firmware. Once you have the binary versions of the firmware, you can use this flashing tool, and you can connect it as I've just done. And then you can go ahead and flash your device. Now, just to kind of save some time, I'm not going to go through the actual process of flashing the device because it takes about 2 or 3 minutes. But once you hit flash, it'll connect to the device and flash a new piece of firmware onto the device. Once you've done that, your device should be up and running. You can get rid of your flashing tool. And now, because I've connected it via a serial port, you can actually inspect your device via a serial port tool. So I can go ahead and connect to this thing, and I can type in a bunch of commands to see if it's there. And that allows me to then start configuring my device, providing input to it, providing output to it, and getting it connected to my home network. Okay, so let me go back to the camera and kind of orientate you, or let me go back to the slides quickly and give you a bit of an orientation of what I've done here. So first of all, we've now flashed this device with a new piece of firmware. Once that is done, we're then able to start configuring this device. So again, just for the brevity of the demo, what I've then done is I've created a second device here. It's exactly the same thing. It's a Sonoff Basic connected via the mains to this controller. But what I've done now is I've connected power into the one side, so 220 volts comes in here, and there's a connection here to a 220 volt lamp globe. I've also connected a little light switch as I depicted in the previous diagram. So I've connected a light switch to that port that I connected the programmer to previously. That allows me now to go and control this device. So let's go and take a look at what this device looks like when it's on the network. So here's my device. Now that I know its IP address, the device, once I flash the new firmware, runs a small little web page that allows me to control it. I'm going to move this over and let you all kind of have a look at my desktop. So let me get my video back up. Hopefully you can see my desktop now again. And you can see there is the device on the desktop that I've connected the 220 volts to. There is the lamp globe. And here is the web page controlling it. So now if I hit toggle on this web page, you can see my light now turns on and off, all controlled by a little web page served from the user interface, from the firmware running on top of that device. It's actually pretty incredible to think that that little device there is serving a web page. The web page is serving on my browser, and I'm able to control that device. But you would remember that I connected a switch to that device. And this is the switch would potentially be connected to the light switch. Now, if I flip the switch at the moment, nothing happens. And that's because I haven't configured it. So part of the firmware allows you to configure what you do and what kind of devices and switches are connected to the controller. So if I go into configuration and I go to configure module, I know that I connected my switch to this pin over here called serial in. That I just happened to solder the switch to that pin on the board that was exposed and ground. So if I configure this, to be a switch now, and I save that configuration, that should allow me to now control my device using the switch. So now, if I flip the switch, you'll see my light turns on. If I flip the switch again, my light turns off. So that's really cool. What we've done right now is we've blown away the ugly Chinese firmware that sits on this device, and we've replaced it with a really incredible open source project that serves very interesting configuration, running on the device, is locally controllable, and does a whole bunch of amazing things, and allows me to not only use it as a switch, but also provide other inputs into the device. Okay, let's pop back to the PowerPoint. So this is the first thing we've done. We've really showed you the first thing. The first thing is a switch, and we showed you how to configure a off-the-shelf piece of commercial hardware, blow away the firmware, and put a switch on it that that we can use to switch most anything, lights, even some plugs. It switches a fair amount of current. The next thing we probably want to do is look at some output devices. So how do we provide output out of one of these things? And to that end, I have one of these demo boards that I mentioned at the beginning that allows us to just prototype some stuff, right? What that's going to allow us to do is I've hooked up a temperature sensor to this device, to this board. You get many different types of temperature sensors. The one I've chosen to use for this demo is called a DS1820. They cost about 20 or 30 bucks each. You have to kind of know a little bit about soldering to connect them up, but you can also buy them in sealed packages where they come made to put in water and all over the show. And I have one of those outside to use as a weather station. So let's flip back to the desk, and I can show you how we configure that device. So if I flip back to the desk, here is the desk. Here is this board that I was talking about. There is the temperature sensor on the board. Let's take a look at the web page of that temperature sensor, and you'll see this configuration looks slightly different. It doesn't have the on and off switch. And the reason for that is that if I flip into configuration and I go back to the configure module section, what I've done here is I've specified the type of this board as type generic. And the reason for that is that in a generic fashion, you can choose whatever you want the pins to be, how you want them configured, et cetera, et cetera. So in this world, I'm able to really almost configure every single pin on that board and decide what I want to do with it. So in this case, I've hooked up the temperature sensor to digital input number 1. And really, it's as simple as going down, finding the temperature sensor that I want to support. And in my case, it's called a DS1820, as I mentioned. So there is the DS1820. I'm going to hit save. That is going to reboot the firmware on the device. And we should get back to the main menu after it's rebooted. And when it gets back to the main menu, I should be able to see that now all of a sudden my device is, what have we done now? Well, right now we've flashed an input device with a switching capability. We've flashed an output device with the same firmware, but with providing a temperature output. The next thing we want to do, guys, is start thinking about, okay, as these devices exist, how do we make them speak to one another? So how do we allow these devices to start speaking with one another? And how do we allow them to connect to controllers, et cetera, et cetera? Okay. So the most important thing is choosing a protocol that you talk at. The reason these IoT devices speak to each other so well is that they use quick, light, efficient protocols. And as the diagram suggested, we really have a couple of options. We can choose a TCP-based connection mechanism. Some of those things speak over a transport layer that happens to not be TCP-based, and we can get into that a little bit just now. And then some of them use some very traditional API access mechanisms that we pretty much all used to, like REST or web service based. However, probably the most prevalent one that most IoT systems end up using is a protocol called MQTT. As the name kind of sounds, it's a message queuing protocol, loosely based off IBM's MQ series protocol. Let me just quick look at what's going on here. Give me 1 second. Let me see my chat window. And that allows us to then speak to devices around very simple protocols, but loosely coupled, which is really, really great in an IoT fashion, because loose coupling in this world is really important. You're not guaranteed that your devices are going to be connected all the time. You're not going to have them on the network all the time, and you don't want your system so rigid that it requires connection. Now, many of you who've done serverless compute or server-based stuff using Azure Message Bus will be very familiar with this concept. So let's quickly take a look at that. What I'm going to do quickly is I'm going to bring over my favorite web browser back again. And in this world of IoT, certainly in my case, what I've chosen to do is containerize all of my applications on top of a Linux machine. So I've chosen to use Ubuntu. The reason I did that was kind of twofold. I wanted to learn and be much more proficient at another operating system. But I also found that the footprint of running Ubuntu on these small devices was great. So I have a small device that runs Ubuntu. You can even run it on a Raspberry Pi, actually. The Raspberry Pi 4s are fantastic at this. That allows you to run Docker on top of those things. Then on top of that Ubuntu device, I'm running a container management app called Portainer that allows us to just view all the containers that are running on that. So let's quickly jump over to the Ubuntu command line, and let's build ourselves an MQTT server. So here I am in my Ubuntu command line. I'm just SSHing into my little Ubuntu server. And the first thing we're going to do is we're going to create a Docker instance for our MQTT broker. There's a really great one. There's many of them, but the most prevalent one is called Mosquito. It's a very light, comes on Docker Hub in a pre-built package. And really all this command is going to do is provision one of those Docker containers. I'm going to expose port 1883 and port 9001 to the open network. And then I've got a couple of virtual directory mappings to map that to configurations on the local disk running the Docker container. So let's go and do that. Let me type in my password. And in a couple of seconds, because I have the image pulled locally, but even if I didn't, it literally takes about 30 seconds if you have a semi-decent internet connection. I have a container up and running, running an MQTT server. There you can see Mosquito is up and running over there. And then if you want to kind of take a look at what's happening there, there's a really cool little utility called MQTT Explorer. That allows you to basically look at what's happening on the bus. So my server is running on address number 13, and I'm going to connect to that. And now I can kind of see what's happening on the bus. So I can see there's a couple of devices connected to the bus. Funny enough, there's one called DevConf Lite and DevConf Sensor. I can see that my temperature sensor's here, and if I look carefully, there's a JSON payload in here exposing the temperature. If I flip my light switch on and off, you can see that I'm getting a message put onto the bus that says my light switch is now off. If I flip my light switch back on, let's quickly take a look at my desktop at the same time, and we can let's try and make this a little bit more easier to see. So if I do that, if I turn my light switch on, you can see I'm getting a message on the bus that says the light is on, and if I turn it off, I'm getting a message on the bus that says the light is off. Very cool. So now my devices are starting to provide instrumentation on where they are and what the current state is. The devices that can receive input, like the light, for instance, can also subscribe to messages. So, for instance, if I published a message on the bus that said, this, the destination address is command devconf light power. So that's the command you put on the bus. And if I type on and I publish that message, you'll see my light turns on. And if I put the command off on the bus, you can see my light turns off. So now I have a loosely coupled system that does pub sub that allows me to start controlling my devices. Very, very cool. So let's jump back to the slides quickly. So what have we done? We've allowed you to connect devices, have inputs and outputs, and now we have a protocol that allows us to speak to those devices, both from an input and an output perspective. Okay, the next thing we probably want to start worrying about is control. So how do we start controlling these devices? From a control perspective, things get really interesting because there are really, really huge open source communities out there that allow us to start controlling our devices. The one I chose to use in my home automation system was something called Home Assistant. Home Assistant actually had an incredible statistic at the end of last year. It ranked number 10 in the year of 2019 for the most contributions on GitHub. So it's really, really well supported, a huge project that allows you to hook up your devices. So without further ado, let's quickly jump into building a Home Assistant configuration. So let's get back to our screen over here. Let's minimize this desktop. Let's bring back our Ubuntu command line. And you kind of guessed it, I have a Docker container to run our Home Assistant instance in. The Docker container, again, on Docker Hub, quickly brings up an instance of our Home Assistant. If I jump back to my web page over here, you will see that now I have a new Docker instance for Home Assistant. Home Assistant lives at port 8123, and if I refresh this page, you'll see very quickly that I now have a Home Assistant new creation on. So let's just quickly create a logon. Let's call it Cliff. Let's create a password, some simple password. Let's detect where I am in the world, somewhere in Johannesburg. Fantastic. And let's finish this up. Home Assistant says, fantastic. I have a new user interface for you. What do you want to do with this interface? Well, the first thing we want to do is go to configuration. We want to go to integrations, and we want to add an MQTT endpoint because that is the protocol that we're using to control our devices. You can guess I'm going to use the same address as I used previously. No need for a username and password, highly secure environment. Really important if you do this, enable discovery, and I'll show you that just now. Now, super interesting. You can see because I've enabled discovery, if I go to devices, it's automatically discovered, Home Assistant's automatically discovered that I have two devices on my network for temperature and for the light switch and the temperature switch. And I can add those devices individually to my user interface. So I'm going to add my temperature one, add my switch one. And if I go to the user interface, you can see now I have some interesting stuff. I've got a light switch and I've got my temperature. But I really don't like the way they do this, so let's quickly show you how you configure this UI. What you do when you configure the UI, let's make this a little bigger so everybody can see it. You can go and first configure how the page is configured. We can remove some of these badges that they create at the top here because they really don't look very nice. Go ahead and save that. Get rid of this weather card. Let's get rid of this switch. Good, now we have a nice clean user interface. So now let's go ahead and add some of the stuff we've just done. Let's say we wanted our light switch there. We can go ahead, it looks for all the light switches, and you can edit this YAML configuration. So anybody's comfortable with YAML, you can edit the config natively if you want. But if you don't, it really works nice and in a nice WYSIWYG fashion. If I flip back to my desktop, you should be able to now see that I now have a light switch, okay, on my Home Assistant page. And now if I hit this light switch, hey presto, my light switch turns on and off from the Home Assistant configuration. I can also go and do cool stuff like add a temperature sensor. I can say, well, actually my temperature sensor is the one called temp. And there's my temperature sensor, and it's currently 22.7 degrees. And and draws me a nice temperature bar graph. And that's starting to look like a real interesting configuration page. So I'm not going to dive deeply into this. You can spend days, weeks, or months configuring this, and I'll give you a quick view of my one looks like, my home production one looks like at the end. But this is a really nice user interface, mobile responsive, so it runs on your phones beautifully. You can expose it to the internet using a secure server so that you can get to it remotely. Really starts allowing you to control and manage your house remotely. Super cool. It also supports hundreds and hundreds of integrations. So although I've shown you just a very simple MQTT interface, you can pull your alarm system into this. You can pull your cameras into this. You can pull your irrigation system into this. They do an amazing job of supporting hundreds and hundreds of different integration points. And on this slide, I've kind of just shown you a very brief view of all the different integrations they have. Right, so the last thing I quickly want to do while we have time is kind of show you what happens if you really want to do automation using something where you need to do automation in a scale that allows you to do very simple graphical automation. So let's quickly pop back to the desktop. Let's quickly pop back to our web page over here and our Ubuntu terminal. For automations, I recommend a project called Node-RED. Node-RED is an automation project sponsored by IBM initially. And very much, if anybody's played with If Then Then That, is an automation project that allows you to visually define automations. It too comes in a Docker container, obviously. And I can provision one of those really, really easily. Once I have that up, I can go back to my Portainer instance, have a quick look here, and you'll see I have a Node-RED instance running. And if I jump over to the Node-RED configuration page and refresh this, you should be able to see that I now have a very simple home automation running that allows me to start defining visual workflows. So think about this as a workflow editor for IoT things. I can do things like take MQTT endpoints, create if-then statements. So let's quickly go ahead and create an MQTT listener. So I'm going to add a broker quickly. 192.168.1.13. Here's my broker on my local network. That's its IP address. Great. I am going to subscribe to some messages for that broker. So remember when we wanted to listen to the temperature sensor. So let's quickly go ahead and find the endpoint for our temperature sensor. The way you do that is if I went back to my temperature sensor, here's my temperature sensors webpage. If you went to the console view, so remember, this is the web server that's running within that actual sensor over there. The console view shows you, just like a console would in any operating system, shows you what's going on. You can see every 10 seconds, this thing's sending out its temperature, and it's sending it across the message, across the network to the MQTT server using that address over there. So that's the address that it's broadcasting its temperature on. So Node-RED over here, I'm going to go and subscribe to that topic. And when I do that, I should be able to hook up a debug node to this thing, deploy that, and we should be able to see our temperature coming in every 10 seconds from the network. Now that allows us to do super interesting things because now I'm getting temperature. But if I inspect this temperature, I see this temperature is a nice JSON payload. JSON's kind of nice, but it doesn't allow me to parse stuff out. So using this functionality, I can do really, really interesting stuff. I can start parsing out JSON. I can start creating control and if statements. I can start doing really cool stuff that allows me to start automating my home network. And I've built amazing pieces of automation with this that really does very, very complex workflow stuff to do things across your home environment. So once you have all your sensors hooked up, you can really get, the world is your oyster. You can really start thinking about how I would automate my world. So for instance, when somebody walks into a room and the alarm detects that somebody is into the room, turn the lights on. When somebody hasn't turned the light, been in the room for a while, turn the lights off. So I'm quickly going to do a quick demo for you. I'm going to import a flow over here. Okay. And this flow now does a couple of things. It listens for that MQTT service. It then parses it into a JSON payload. I then have a switch statement that says, is the temperature above 25 or is the temperature below 25? If the temperature is above 25, it creates a command. It sets the payload to on. And then it sends out a command on the MQTT bus to the light to turn the light on. So basically, we have a temperature-dependent light. So let's go ahead and deploy that quickly. Turn this logging off over here. And we should be able to see our temperature come out here in a couple of moments. And if all goes well, we should be able to control our light switch from here. Okay. So let's pop back to the slides quick. So what have we shown you? We've shown you how to connect a bunch of things, both input and output. We've shown you a protocol to connect them with. We've shown you how to control them, both in a user interface way and in an automation way. And then I've shown you briefly a user interface around that. The last thing I kind of quickly want to get to then, is while we have time, is just kind of what this thing could look like. So I'll give you a quick view of what this looks like in my own home. So here's my home user interface. You can see that I've pulled in a whole bunch of devices, including my alarm system, some weather data. I have power sensors. I have temperature sensors outside. I'm monitoring my daily energy usage through power sensors in the main DB board. I have a simple switch that's counting tips, that's measuring the amount of rain at this point in time. I have almost every single light switch in the house connected with one of those Sonoff devices. So pretty much every single light switch in the house has one. And I can control every single light in the house with one of those devices. And I have pretty sophisticated automations sitting behind those automations to turn lights on in the evening, to turn them off in the evening, etc., etc. So with that, I think we've got time for a little bit of Q&A, but first, before I jump into the Q&A, the last couple of tips and tricks. First of all, if you do want to get into this, make sure that you have decent Wi-Fi in your house. Wi-Fi is really, really important, and the coverage of the Wi-Fi is important if you're using Wi-Fi connected sensors. There are other sensors that work over wireless protocols, that you can use bridges to connect to, so that is an option. But even in that world, you need to make sure that your connectivity to those devices is good. Otherwise, you're going to cause yourself endless frustrations. My recommendations for Wi-Fi are either Ubiquiti networking equipment or the Google Home Wi-Fis. They're both excellent, provide really good coverage to the house. I crashed. outage, as the luck would have it. So I hope you're back with me. If we do have time, I can still do a bit of Q&A, but let me just quickly finish up on my recommendations. Second recommendation I recommend is Docker. Make sure that you take a look at that. If you're not familiar with Docker, the learning curve is not too bad and really, really helps you get multiple versions of this up and running at one time. Third one, take a look at your power and your internet connectivity in your home. It's really, really important if you're going to do this and if you want the family adoption of it, that you have some type of UPS, especially with the ESCOM trouble that we all have at the moment. Third tip I have is family adoption. Think about your family and the usage of this. It doesn't help you go and automate your home and nobody knows what the hang is going on. So make sure you include your family in this. Ask your kids what they want done. Ask your wife what you want done. It's a cool term called wife adoption, acceptance factor. If you get your wife to buy into this, you'll have lots of freedom to play with the stuff. If you don't, you'll get your wings severely clipped, and vice versa. There's a whole bunch of really amazing women on this community that do stuff, and their husbands are the acceptance factor. And the last kind of tip that I have is don't be scared to be a maker. Some of the stuff requires you buying a soldering iron, soldering a couple of wires to a board. You really don't have to be an electrical engineer or a technician to be able to do this. They're very, very simple connections. Most of the stuff is off the shelf. There's amazing videos on the internet that show you how to do this. So don't be afraid to try and get into this as a maker. And if we have any questions, happy to take some questions. Okay, quick question. Do range extenders negatively affect the connectivity? No. So range extenders will work. Just make sure that they're good quality ones. Watch the number of SSIDs that you have on your network. Try and standardize on one SSID because it becomes really tricky to manage when you have multiple devices on your network. So just watch your Wi-Fi kind of design. So if you do use range extenders, make sure that you partition them well and watch your SSIDs. Another question by Rochelle. How do you manage the Ubuntu server running Home Assistant with power cuts? I have a Raspberry Pi running Home Assistant and the UPS keeps keeping it alive, but it still causes havoc. Okay, great question. And I think I mentioned that in the tips. I do have there's two ways to approach that. One, take an old laptop that has a battery in it. If you have a laptop with a battery running Ubuntu, it really lasts through most power outages, especially because it's not running with huge amounts of CPU cycles. But if you can connect it to a UPS, that makes a huge difference. Secondly, on the Raspberry Pi, subject, be very careful running Raspberry Pis with micro SD cards. There are great articles on the internet of how to run Raspberry Pis using SSDs, both on the 3 and the 4 version. I suggest you do that. Buy a cheap SSD, buy a SSD USB cable, and run that. It's much, much more stable if you run your Raspberry Pi instance on an SSD. What UI are you using for your home? Craig Nicholson asked. I'm using Home Assistant. I use it both on my phone. I use it on a big tablet. I have stuck to the kitchen wall, and that one's actually pretty interesting. When you stick it on the kitchen wall, it really helps with the home adoption. So my daughter will walk up to it, turn the home alarm off. My son will change the lights in his room through his iPad. So if you have a great user interface, it really makes the adoption so much more easier. Amazing talk, geez, thanks. How easy is it to expose things like Google Home or other audio systems? Yeah, it's really easy. So both Home Assistant natively supports both Google Home and Amazon Alexa. Hope I didn't trip anybody's devices there. There are great wikis on how to do it. The Node-RED automation process that I showed you also natively supports Amazon Alexa in a local loop, which I use a lot, which means it doesn't have to go up to the cloud. And I use that a lot in my kitchen to control things like lights, turn off the alarm, etc., etc. Those are the questions, and that brings us to the top of the hour. So thank you very much, everybody who attended. It's really weird sitting in my room, not seeing your faces. I wish I could have seen your faces, but I'm really glad we got to do this. I think you all know my Twitter handle. It was on the slide deck. If you really want to know any questions, if you feel free to reach out to me on Twitter, via email, via WhatsApp, whatever you want. I'm really passionate about this stuff. It's an incredible community, and I think the more of us that get involved in this, the better it will get. So thank you very much for your time.